So hello guys, on my channel I just posted some information about the levers in my Telegram channel, and I wanted to find some interesting tasks that you'll find on your GCSE exam. So let's take a look at how can we prepare ourselves for such tasks. So as you can see, this task is about a moment of a force. Actually, when we talk about a lever is a mechanism that uses a moment of a force, and it is based on those characteristics. So the first question to you is to find which of this is a unit for the moment of a force. So for a moment of a force, you need to know that a moment of a force is found using this equation where we multiply a force by the distance. So it's actually a perpendicular distance, which is important to understand, a perpendicular distance for a force. So here is this equation of a moment of a force. And using this equation, we can understand that the units for a moment of a force are as such. For a force, the units are newtons. For the distance, units are meters. So when we multiply newtons by meters, we get Newton meters, right? So the right option here is C. Then let's do question B. Figure 15 shows a claw hammer about to remove a nail from a piece of wood. So here is a simple lever machine that shows that here we have, no, actually we have it right here. Yeah, so here is the load. Here is the effort. And here is the turning point, you see? So kind of a system like this. So three most important places: an effort, a load, and a pivot, of course, a turning point itself. So they want us to state the principle of moments, and they give us some distances here. As you can see, this is our pivot. And there are two distances, yeah? So we should, at first, what the principle of moment is. It's the principle that stands that the clockwise moment equals to the anti-clockwise moment. So this is the principle of moments. Basically, if you know that the moment is calculated like this, then to find the moment of the first with clockwise rotation, we just need to multiply F1 by Fd. So in our case, F1 and AD is this force of a load, yeah, of an effort. Here we have an effort. So here is where we apply our arm, our hand, to move this hammer and to get out a nail from the hole. So this thing equals to F2 times D2. So equals to moment, second moment. Okay, this isn't a division, sorry. It's just the way I want to highlight things. So I wanted to highlight it. Maybe let's click this is a better way. So this is the principle of moments. Here is also a principle of moments, but written more precisely. You see how interesting that D is shown here. You see, this is very important. I told you that D should be perpendicular distance, and you can definitely see that it is perpendicular. Why is it perpendicular? It is considered perpendicular because the turning point, the pivot, is right here. So from the turning point and the force, the distance must be perpendicular. Not like this, not like this, which is a mistake, right? A very, very tempting mistake. But please make sure that the distance is perpendicular, and whether you got some harder tasks, please not make this mistake. So here in the picture, it's a great example of perpendicular distance. 90 degrees here, 90 degrees here, from the turning point to the effort and to the load. So this is how we state the principle of moments. Now our task is to calculate question 2, sorry, calculate the force F2 shown in figure 15. So look, we have all the parameters. Our task is just to substitute it into the principle of moments, and we can calculate force 2. Also make sure that the units are given nicely. We don't like the centimeters, right? Our units are Newton meter, sorry. So here we need to, at first, convert. How do we convert centimeters into meters? Little task to you. Well, when we move to a higher thing, we should divide. It's very tempting to multiply, right? But we should divide by 100. So 0.245 meters. And here we get 0.037 meters. These are our distances. So now we should rearrange this thing to calculate F2. So to calculate F2, I'm giving you a moment to think about it. How do we rearrange this thing? We should take this thing and put it at the top in the numerator. And this thing that goes next to F2 goes to the denominator. Like this, travels there. Okay, so now we just simply substitute. Newtons are okay, we don't need to convert them to anything. 245 and divide by 0.037. Let's calculate using the calculators. I hope you have engineering ones. Let me use mine. I'm not sure if I'm going to put it into the internet, on the internet. But why not? I just want to do it finally, and I don't like it. It's very hard, even though I know that I calculated correctly, but I hate it. Look, guys, I've just finished my calculations. It's got to be 75. Do we have any information? How do we round it? 75.5 then. We don't have any information. How should we round it? So thank you guys for being here. Please write down your questions in the comments down below. So maybe you have some topics or some tasks that you'd like me to explain to you. So feel free to contact me for any information you want to know. Thank you.